Welcome to our NPTEL courses on the power quality improvement technique. We are continuing with the sources of the power quality, and we are actually discussing on the capacitor advantage of the capacitor. Now, we will talk about much disadvantage of this capacitor, which will improve the power quality. So, one of the major drawback of this capacitor is that the harmonic resonance. Why this comes? What happen, most of the you have a transformer, and generally you have a distribution system, and this distribution system may have a adjustable speed load and maybe a inductive load, induction machine. And once it start to nullify their effect, you have switch on the capacitor bank. This is CB stands for the capacitor bank. Now, what happens once you close it? So, there is a leakage reactance of it that has some value, and this capacitor you have calculated based on this the power factor you wanted to bring the power factor at 0.95. Then what happens, this adjustable speed drive will produce here some amount of 5th, 7, 11 and 13 harmonic, and so on, these devices. And this adjustable speed drive can produce some harmonics. This it may be the 5th harmonic, quite dominating harmonic. That 5th harmonic and this leakage reactance of inductor and this capacitor can set a 5th harmonic resonance, that is actually omega 0.5 can be under root of XL and XC. Then what will happen? It is basically L leakage and LC. Ultimately, you have chosen a capacitor to mitigate this problem, but this entity is there. This entity will have a 5th harmonic and it will cause a 5th harmonic resonance. If 5th harmonic resonance occur, please understand that 5th harmonic is a negative sequence, because if you are sitting on a 6th harmonic, that is cophasor, then 5th harmonic is rotating with an clockwise with respect to you. That is what ultimately then, due to the resonance, this 5th harmonic value will aggravate, and this will go to the machine. It is because of the source inductance of this wire, this 5th harmonic voltage also will be generated, and that will go into the machine, and ultimately it will produce a ripple torque and the torque negative to the fundamental movement, and thus clogging will take place. So, this is a very big disadvantage of this capacitor. Let us go back to our discussions. So, this is a good entity or things at a fundamental frequency 50 or 60 hertz, and the result in the current and the voltage being in phase with the utility power factor. That is a good part of it, but worst part of it that it may cause the harmonic resonance. However, it is not good when it occurs at harmonic frequency. If resonance occurs at a harmonic frequency, that is what I was discussing, the harmonic current reaches at a maximum value and causes the overheating of the transformer, capacitor and motor, tripping of relays and incorrect meter reading. Because these meters are being calibrated for the sinusoidal operation. If you feed a non-sinusoidal voltage and current, it will not give you the proper reading. How does the resonance occurs at a harmonic frequency? That is what I was discussing. The amount of the inductive and the capacitant reactance are dependent on the frequency of the voltage and the current. This resonance can occur for the at a various harmonic frequencies. What is the fifth harmonic? That is what I was taken, and it may have and this formulates the inductive and the capacitive reactance as illustrated below. So, capacitor can cause two type of resonance, one is parallel, another is series. So, if it is a parallel resonance, this is an anti-resonance essentially, the least current will flow. Your admittance is minimum, thus impedance is maximum. Since most power factor improvement capacitor are in parallel with the inductance of the power system, such shown in the scheme of the parallel resonance circuit in the next figure, that is in figure 6, we will have a parallel resonance, and parallel resonance what happen? It is behaves like a resistive network, but with a high value of impedance. So, it does not, and ultimately since it offers a very high impedance, then current takes a different path to flow. When the capacitive and the inductive reactance is connected in parallel in the power system, the magnitude of the total impedance can be calculated. These are the calculations, this is an elementary calculation, but there is a problem. Harmonic reactance occurs when XL equal to XC, or rather it should be admittance should be matched rather. So, XT becomes purely resistive, and according to the Ohm's law it is this, thus resonant frequency is under root of LC, and it may be due to that what I have drawn there, a step down transformer, an untuned capacitor bank, and there is a harmonic current because of the adjustable speed drive, and thus a resonance path has been set. So, how to prevent the resonance? One, we should calculate the leakage reactance, but leakage reactance is also the function of current. So, there will be have a different leakage reactance of the inductor at the different of the transformer, because you have not physically inserted the inductor there. So, we prevent the resonance by sizing and locating the capacitor to avoid the harmonic resonance frequency by using a filter, and we can use the passive filter and we can use the active filter. In your subsequent classes we shall discuss about both the filters, passive as well as active shunt active power filter, and there and also this static capacitor bank is generally replaced by the STATCOM, and it eliminates this kind of resonance. A filter, simply an inductor and a series with the capacitor, is shown in the figure, next figure. Filter detune the capacitor away from the resonance frequency. Filter usually costs twice as much as the capacitors. Filter also remove the effective distortion of the power factor and increases the 2 power factor. This is the advantage of it. So, we require to replace it, this capacitor bank, with the inductor, and we can take a help of the fax devices also. There you can have a TCSC. So, all those entities can be placed to improve the value of the capacitor. So, untuned capacitor we cannot use, but you get a better performance, but at some cost. Please understand it, because you have to have a high value of the capacitor as well as the good amount of the cost come from the inductor. This inductor you have not connected, it is there because of the leakage reactance of the transformer, but you require to physically connect an inductor and you make it a tuned capacitor bank filter. We will discuss in details while designing the filter. We have a total class, 1 or 2 class I have dedicated for it, for discussing this entity. So, the true power factor. The true power factor is the power factor caused by the harmonics and the fundamental. While you may ask, actually, I just can't take this question little later. While the standard or the displacement power factor described previously caused by the fundamental power at 50 hertz, and it is not measured by standard VAR or the power factor meters. So, true power factor we require to take a cognizance of the harmonics. For this reason, real power in kilowatt, that is something what you are consuming, because if you have multiplied sin n omega t into sin m omega t and integrate over 0 to 2 pi and then take the average of 2 pi. So, and you can see that this power gives you 0. So, harmonic power is generally, if you average out, this gives you a 0 value. But problem lies, once it flow through the resistance or other network, it loses the power, it has to be accounted somewhere. It is like that you transfer your friend some amount of money, he transfer back some amount of money to your bank transaction, but banks eat out in case of some amount of money, if the bank transaction charges are quite high. So, then this kind of questions arises, and due to that we require to have a factored in the harmonic power. So, the total power in kVA or VRMS or this VRMS into IRMS, where IRMS in it all the harmonic content are there. So, we require, if when you talk about IRMS, then it is let us go back. So, when you are talking about VRMS and you have a content of this all the fundamentals and the harmonic, then V1 square plus V5 square plus V7 square plus V11 square all has to be factored in, and that value will be your VRMS. Okay. And similarly, your output has to be all I1 square plus I5 square plus I7 square plus I11 square and so on. In that way we require to produce the harmonics, and thus we have to represent this. We will discuss later in the case of the shunt active power filter, this theory, that is the instantaneous reactive power theory, and there we shall place the reactive power as well as the harmonic power, and thus we require to represent it into the plane. This is the kilowatt and this is the kVAR, and then if there is no harmonic, ultimately you can take the resultant, that is fine, that is your kilovolt ampere current, apparent current, but there is a harmonic distortion, and thus it forms a cube or parallelepiped, and ultimately this diagonal essentially gives you the magnitude, that is the kVA with the harmonics, that is the symbols of kVA with the harmonics. So, new definitions comes and we have to pay for that power factor also. We require to maintain that power factor also less than 0.95. So, as we can see from the diagram, the true kVA is larger than the displacement kVA because the effect of the harmonics distortion. The even though there is a no penalty associated with the 2 power factor till now, still has a detrimental effect on the power system, and we are coming to it, the effect of the poor power quality. This is on the subsequent lecture itself I will take this issue. The true power factor means increased losses and reduce the system efficiency or the system capacity. The true power is increased not only by addition of the capacitor, but by elimination of the harmonic by use of filters that can be active or passive. So, nowadays we are looking for the solution with the active filter. The addition of the capacitor can cause the true power factor to be worse by magnifying the harmonic distortion, that is the problem of it. So, we are discussing several times that another cause is poor grounding and poor wiring. So, see that how this causes the problem, and this is abbreviation of the European Union. So, survey found that poor wiring and grounding in the end users facilities causes 80% of all the power quality problem. So, some power quality is also for the poor workmanship. The National Electrical Code NEC determines the design of the wiring and grounding. However, we have taken a special class, we have also covered the standard, there we have discussed in detail, but let us look at here also. So, it is the continuation with the discussion. However, the NEC as described in section 91B is intended to protect the people from the fire, electrostructions, and not to protect the sensitive electronic equipment from damage. So, this is something, please understand it. So, the NEC code is for fire and shocks and all those issues, so that once you touch the machine you should not get a shock. Wiring should be that. Electrocution does not happen. So, that whole body whenever you touch an equipment you should not get a shock, but it is silent about the harmonic distortion or any other issues may damage your complicated electric circuit. That is not in a domain of this national code. As a consequence, there is a great need to establish guideline for wiring and grounding that not only protects the public, but prevents the power quality problem. We have taken care of only hazards, but not the power quality problem as such by this National Electric Code. For this reason, this standard required to be modified in every couple of years, maybe as far as that a new problem arises, and then it has been reported, and then we require to have. For this reason, you will find that there are so many clauses, sub clauses and all those things. So, symptoms of the poor core quality grounding includes computer that lost data and stop operating. Sometimes you may see that due to the poor grounding problem, your processors somehow your chassis has not been grounded and get a high power, and capacity effect comes, and due to that your processors has been loaded unnecessarily with the capacitive current, and that gives you the heat. If you are not able to take out the heat by your fans, then of course the longevity of your computer will be suffered. Telephone system that lose calls or are noisy, that you have noticed several times. Industrial process that suddenly stop. Due to this, I was talking about, let us say you have a resonance with the fifth harmonic and you are running a motor, and what will happen, this all of a sudden due to the high contamination of the fifth harmonic, it will crawl. Breaker boxes that maybe get very hot because of this problem. Neutral leads because all the current, it is because of the unbalance will flow through the neutral, and neutral leads that the catch fire. Even power conditions equipment like transient voltage surge suppressors, and it may also catch fire because of the improper designing and grounding. Guideline will help to identify the problems caused by the inadequate wiring and the grounding problem. Of course, because of this itself is a course of our engineering BTech study. So, we require to take care of these issues quite well. Unfortunately, due to the lack of time, I cannot go into that detail very much, and that guideline can be divided into the three categories. One is wiring. So, you should ensure that loads are distributed in all the phases of the house in a right manner, so that you do not inflict huge amount of this unbalance into the system. Moreover, if some portion of it has adjustable speed drive, then try to contain the adjustable speed drive harmonics and give a sinkage path, so that it does not propagate to the whole area of this power network. Thereafter, grounding has to be done very properly. If the ground does not, if high current required to sink through the ground, the neutral may burn, as well as what happen if you do not properly ground it, then there will be oscillations of this neutral point, and thus there will be a low, if it is not at 50 hertz, then there will be a subharmonic problem also, that is also a challenge. And thereafter, lightning protection, that is a common practice what we are doing for the pretty long time. I show you picture maybe in the next slide, next to next slide, then only we will clarify how does it work. And the solution is not to connect the non-sensitive load that interact with the sensitive load. So, you have a big machines, and and beside that you may have a laptop. So, you should not keep with the same power supply, you should have a segregated the power supply. Wiring sensitive load to separate circuit connected to main electrical devices panel, separate sensitive load for the non-sensitive loads. So, your pump in a domestic house and the computer required to be kept in isolation. Poor grounding can cause voltage and the potential difference. Excessive ground loops and interference and the sensitive, and it can interfere with the sensitive electronic equipments, mostly the sound system affected the much. I have noticed in a hall, because of the poor grounding, is acoustics is poor. So, proper grounding not only protects the people from the shock, but provides a reference point and a path of the large current caused by the fault, like switching surges and the lighting electric lighting strokes, etc. Poor grounding can result in lightning destroying equipment at a home and the factory. So, if you not properly ground your all the entities, ultimately if lightning strikes, I know a case where all the fans were destroyed and ultimately lightning takes the least resistive path, and that was the least resistive paths, and ultimately your surge arresters does not work properly, and all those electrical equipment was burned. So, that is what I am saying, the lighting surge will take the path of the least resistance, you have to provide the path of the least resistance. Wiring and the grounding should be designed to divert the lightning current away from the sensitive equipment. You have to pass the bypass equipment to ground through the lightning protection devices such as lightning arresters, such protections I am showing in the next figure. So, this is the case, thunder, it is striking maybe here, and you try to have a entity here, otherwise it will propagate here and it will propagate here, and ultimately since it is the least resistive path here, it will go through here. And what will happen otherwise? So, it will have propagated to this tower, and then it is open circuit, and then again it will reflect back, and ultimately through it the surge will come to the transformer. From this transformer it will enter into the system, and maybe it will destroy the sensitive equipment in the control room. So, we have to provide the surge arrestor here as well as here, so that it has been arrested locally. So, another important entity is the electromagnetic interference or EMI. Another source of the power quality problem is the electromagnetic interference. Some devices like large motor during startup emits electromagnetic fields and interacts with the adjacent sensitive devices like computer, telephones, etc. Michael Faraday's transformers law explains this phenomena very well. So, it is nothing new for us, but how to mitigate this problem, this is also a big challenge. Transformer law says that when an alternating magnetic field cuts the adjacent conductor, it will induce an alternating current and the voltage in the conductor. So, unless you have magnetically screened that particular area, so in your machine lab you are sitting, a phone is placed, so phone will have a problem because of the magnetic field. Induced current and voltage can damage the sensitive electrical equipment, or it will cause to malfunction. So, hazards of the electromagnetic interference. Sensitive equipment in hospital often experiences EMI problem. So, generally you have X-ray machines, then you have a high electrostatic voltage to general X-ray. You have a MRI, that is essentially the magnetic resonance. So, you create a huge magnetic field. If those entities are not properly screened and segregated, those entity will introduce high electrostatic field as well as high magnetic field. They are generally changing, and they will interact with nature and will cause a electromagnetic wave. And this electromagnetic wave may interfere with the highly sensitive other monitoring devices, and it may be hazardous to the patients largely, and thus it may malfunction. For example, in one open heart surgery training center, electromagnetic field from an adjacent electrical equipment room has causing the heart monitor to read incorrectly. So, this is a big problem there. the moving cable emitting the electromagnetic fields at a safe distance from the cable feeding the heart monitor may solve the problem. There are many ways to solve the problem. This is altogether EMI EMC suppressions issue. So, that can be a banded method, that can we have a holistic designing methods. So, that itself is a chapter or a subject. Now, another entity is essentially the static electricity. So, another cause of PQ problem is the static electricity. So, static electricity occurs when rubbing of one object with another and causes sometime a high build up voltage build up. For example, you can build up an electric charge on your body when rub your shoes on a carpet. Discharge of the static electricity can occur when you touch a grounded object like another person's or a metal object. Though the static electricity problem is infrequent and they generally overlooked, but sometimes it may cause a huge problem. Static electricity can create as high as 3000 volt and more and damage sensitive electrical equipments. And for this reason, we require to reduce the static electricity sometime by increasing the humidity, then insulations of the air decreases, changing the carpet and clothing. Also you require to wear, instead of the silk you are required to wear cotton clothing, furniture with the furnitures to non-static type, so that it does not hold charges, grounding the person with the piece of the equipment with the wrist strap. Mostly it is used when these technicians are shouldering the MOSFETs, because their hand may contain, if you rub it you have a sufficient amount of charge, and once you touch with the hand, then this charge will go to the will be tapped into the between gate and source of the MOSFET, and thus it will be automatically on. So, ultimately you get a MOSFET in a short circuit condition. For this reason when they are soldering, they wear the wristband. So, same happens. So, since sensitive power electronics devices are made of MOSFETs mostly, so these static charges if some way come into this gate and drain, then it may function abnormally, and that is also you can take it as a power quality problem. So, for this reason the static charge will cause a power quality problem. So, let us come to the last part of our discussions. What is the effect of the power quality problem? The effect of the power quality problem are many and varied. We can talk about half an hour, but I just put a gist because of the many recall type question can come from this part. Please listen carefully or go through the slide. When the utility customer calls the utility in an attempt to determine the cause of the power quality problem. However, most of the power quality problem manifest themselves. Some affects the end users and the electrical equipments. These symptoms includes motor overheating, adjustable speed overdrive tripping off, computer shutting down, flickering of lights and stop production. Effect of power quality problem can be best understood by looking at the various type of the load that are affected by the power quality complaint, including computers, consumer products, lighting, meters, ferromagnetic equipments, telephone, manufacturing process and the capacitors. All are being affected by this poor power quality problems. Computers and the computer control equipments freeze up and lose data. Now, data is now new age fuel, please understand it. If you lose the data, you lose the business. Most power quality problems are now problem on computers are caused by the mostly the voltage variation. So, you require to give a regulated power supply, and another maybe the consumer products includes digital clock, microwave ovens, television sets, video cassette recorder. Now though it is going out, it may be a CD compact disc, stereo equipment affected by the voltage sag, and outages caused by the electronic timers to shut down. This problem manifested by the blinking clock. Lightning also a problem, and lightning it is not lightning, it is lightning. So, includes the incandescents, high intensity discharge, and fluorescent light. Incandescent light often dim during the voltage sag and it does not turn on. That is what it is found most of the villages in at least 5 years ago also. So, I find that in evening that voltage due to the sag in the voltage. So, your tube this this fluorescent lamp does not work. All lighting will flickers when arc furnace and arc welder cause voltage fluctuations. Due to flickering, it will give a stress on your eyes and you may have a many health problem from that. Meter gives a erroneous reading in the presence of the harmonics. Ferromagnetic equipment include the transformer and the motor overheats and lose life when harmonic current increases the loading them. Telephones experiences noises, so you cannot hear properly. It is adjacent electrical equipment. Adjacent speed drive not only cause harmonic, but are affected by them the frequent shutdown of the adjustable speed drive, usually indication of the excessive harmonics, and also its life reduces due to that because of the high contamination of the harmonic. And manufacturing processes, this is one of the important entity, experience frequent shutdown due to the voltage drop and voltage sag. I have recently experienced this problem into a sugarcane mill in Uttarakhand. They have a problem of the frequent shutdown and they come to us for the solutions. So, and I have seen there how their production has been hampered, and capacitor can amplify as well as draw harmonic current from themselves. This often cause the capacitor to fail or to be tripped offline. These are the overall overall sources and the effect of the poor power quality. Thank you for your attention. We shall continue our discussion with the power quality improvement technique in our next classes. Thank you.